With the quantities, continuing on in Unit 4, calculate the grams of sodium chloride that is produced if 3.65 grams of hydrochloric acid is reacted with sufficient, that's an important word, in sodium hydroxide. Okay? Probably not the best example, but it's an example nonetheless. It does technically give us a chemical reaction, even though the chemical reaction isn't the best one ever. Okay? So there are some things that we can look at and put together. Grams of sodium chloride is produced. Means sodium chloride is a product if it is produced. Okay? And so we say that sodium chloride is produced. Well, what made it? What are the reactants? Hydrochloric acid is reacted with sodium hydroxide. Okay. Now, the fact that it's sufficient sodium hydroxide might not mean a lot to us right at this moment in time. And by beginning of next week, it will. Okay. Now, there's one thing that is not yet given to us, and that is the other product. The only things that aren't being kind of accounted for yet, and that it's water. Okay. Water is a product in this reaction. By the end of next unit, you'll know what type of reaction this is. It's an acid-base reaction. No, that's why it's an example and I added in there. What we should be able to look at is say, hey, hydrogen and this hydroxide aren't accounted for over on this side yet. And that's what makes the water. Okay. So let's resize it. Because we got some calculations to do now. Okay.
I can't read that. Sorry.
So we have, and the fact that it is balanced does also help us out quite a bit. That we have that written in. We do need to identify what we're given and what we want. .65 grams of hydrochloric acid. I want grams of sodium chloride. Now that we have kind of our given and our want, the other thing is, it is balanced as it's written. So this one's nice. Doesn't require any balancing. Everything's going to be 1-to-1. Okay, breathe a sigh of relief. I need to find the molar mass of my sodium chloride. I also need to find the molar mass of my hydrochloric acid. And it's not done any differently. We do it the same way, like always. Whether it be just, hey, find the molar mass of this, it's the same if it's in the middle of a stoichiometry problem or if it's just find the molar mass of this compound. And so, therefore, we go through that whole process, and again, it's the same. We have to look on our periodic table to find the molar masses of the elements themselves, just like we always have. Your other option is memorization. I highly suggest just utilizing the tools that were given. We have to multiply them. Well, 1 times any number is that. And so we now should be able to add them together to get 36.46 grams per mole. Now you need to do the same thing with the sodium chloride. And one of the things that a lot of students are going to start to realize, a lot of times something in this compound is connected to the want. So there's usually something that's connected there. This time the connection is chlorine. Because there's one of them and I feel we're intelligent beings, I can write 22.99 and 35.45 and not have to show the multiplication of 1 times those. We would add those up. Four, carry the 1, and then I believe it's ran out of space, but the label would be grams per mole. Okay. Now it becomes the conversion problem. Now it becomes the, all right, what do I start with? What am I given in the problem that I have to start with and start solving with? Well, I'm given 3.65 grams of HCl. I then need to convert that into moles. The only way I know how to convert that into moles is using the molar mass. That's why labeling is so important, so that I know which one of these to use and when. And so I use 36.46 grams HCl per 1 mole of HCl. Now that I have it into moles of HCl, because the labels cancel, I can now convert from moles of one thing to moles of another thing. And this is usually where students go, I don't know where I can get to here, but I just don't know what that step is. And they go, look at your chemical reaction. If you get stuck, double check that. How do I go from one to the other? And it's always going to be the mole bridge, or this step right here, when we convert from moles of hydrochloric acid to moles of sodium chloride. Now, there isn't a number written in front of these because there isn't a number. That means the number is 1. My labels cancel out. Now I have moles of sodium chloride. Is that what I want? No, I want grams of sodium chloride. Therefore, I have to use my molar mass that I've already calculated. And to do that, I multiply and I would have my labels will cancel out. And my label is now ultimately what I want. So now I kind of can condense it down a little bit and multiply across the top and multiply across the bottom. This one's usually pretty simple because it's 1 to 1. So it ends up being 3.65 times 58.44 divided by 36.46 to give us an answer of 5.85 grams of sodium chloride. So in this problem, we should be able to figure out in a reaction of this with this. Okay, silver 1 nitrate. Formula for silver. Ag. Nitrate. NO3. The fact that it's aqueous just means we got to add a little AQ there. With sodium chloride. It's also aqueous. Now would be a good idea to double check our charges before we go on. Silver 1 has a charge of 1. It's in the name. Nitrate, -1. We're good. Sodium, group 1, +1. Okay. Chlorine, -1, group 7. All of them have -1. We're good. So this one's also going to be a nice one. Why? Because it's going to be 1 to 1. If all the charges are 1s, positives and or negatives, you're not going to have something crazy happen on the back end of this. So, aqueous sodium nitrate is produced. Sodium nitrate is produced. Aqueous. And grams of silver chloride. Well, that kind of infers that a solid is made because it's measured in grams. We'll learn the why next unit. Okay? Let's identify our givens and our wants. I'm given silver chloride. So I'm given My want how many grams of sodium chloride? Okay. So I have everything. Do I need to find the molar mass of the ununderlined items? No. You can if you want. It's practice. But you don't need it. If anything, I find it more confusing for students to do it that way. Why? Because then you have numbers that you're not going to use and you're going to feel obligated to use them. And that's not good. That's why underlining what you are given and what you want can be beneficial. You're focusing on really everything that you need to calculate. Okay? So I'm going to resize this so that I have some room to work. Now, I will need to calculate out the molar mass of sodium chloride, which was on the previous one, but we'll do it again. Because it's one of everything, and 1 times a number is just that number, I'm not going to multiply it by 1 or showing me multiplying by 1. I look in my periodic table to find the molar masses so that I have my molar masses correct. Now, what's going to be different is now this one has silver, and we haven't used silver yet. It's also just a 1-to-1, so I can write that in as such. So I need to look on my periodic table for silver. And this one usually ends up being the one that's a little bit more debated. Is it 107.87 or 86? I would say 87. My chlorine doesn't change. I add those up. To give me an answer of 143.32 grams per mole. Now that I have my 2 molar masses, I can start the conversion problem. Why are these just really hard conversion problems? Because you have to find some of your conversion factors. It's really all it becomes. Okay? My given is 2.99 grams of silver 1 chloride. If I want to get rid of the grams and move it into moles, because when in doubt, convert to moles. Because then we can do a lot. We use our molar mass of our silver chloride, which is my 143.32 grams of silver chloride, moles of silver chloride, Now, some people might find it easier. Punch that number in and hit enter. Then convert from moles to moles. Punch that number in, hit enter. Then convert from moles to grams. Punch that number in and hit enter. You're doing the same thing. Okay? However, I just don't find it as successful ultimately. Silver chloride, moles of sodium chloride. Because everything's a 1-to-1 and require no balancing, I can put ones in my mole bridge, my stoichiometric ratio, my molar ratio. Now that I have it in moles of my want, I use the last number that I have, and that is my molar mass of my want. Now I have to do the final multiplication and take 2.99, multiply that by 58.44, divide that whole quantity by 143.32 to say that my final answer is 1.22 grams of sodium chloride was in my original solution.